These are notes from section 4.5. This is day 3 on section 4.5. 4.5 is on integration by substitution. Just a couple of quick examples here. This one asks for the integral of x times the quantity x minus 5 to the 6th dx. So we're going to use substitute. We're going to make u equal to x minus 5. When I get the derivative here, du is equal to dx. So when I go to rewrite, I've got dx is equal to my du. This becomes du. Here I've got u to the 6th. The problem is we have this extra x out front. Usually that x becomes part of my du, but this time it does not. So the problems we're looking at are if we have an extra variable out front that does not become part of the du, what to do. What we're going to do is I need to change this to a u, and I have an equation right here that relates u and x. U is equal to x minus 5. Or if I solve this for x, it would say x is equal to u plus 5. Add 5 to both sides. So I can replace x with u plus 5. This equation looks very similar to the one we started with, but the one we started with, I cannot distribute this x because I have a quantity to the 6th, whereas here I have a quantity to the 1st times u to the 6th. I can distribute this u to the 6th. So I get the integral of u to the 7th plus 5u to the 6th. And now we can integrate. And as always, you want your final answer back in terms of our original variable, which was x. So replace u with x minus 5. That is a perfectly acceptable answer. If you are checking your answer either on Slate or the back of the book, odds are good that they factored out x minus 5 to the 7th from both of these and also factored out something that goes into both of those. I would just leave the answer like that. That's no problem. Example 2, one more. Let's do a definite integral this time. The integral from 6 to 8 of x times the quantity 1/2 x minus 3 to the 4th dx. So we're going to make u equal to 1/2 x minus 3. Du would be 1/2 times dx. So I need to multiply by 1/2 to make my du. I need to cancel out that 1/2 I just multiplied by multiplying by 2. 1/2 dx is equal to du. This becomes du. I just bring my 2 down. Here I have u to the 4th. And again, the problem is I have this extra x in here. You can move constants, you can move coefficients out front. You cannot move variables out front. I cannot take this x and move it out front. That's not going to work. So we need to replace this x. We can do that by solving this u equals equation. So that would say u plus 3 equals 1/2 x. Multiply both sides by 2. And we get x equals 2u plus 6. So when I go to change to u's, it looks like this. 2u plus 6 times u to the 4th du. Don't forget to change your bounds. When we have a definite integral, these are x values. When I rewrite it in terms of u, I want those to be u values. Plug 6 in for x right here, gives me 3 minus 3. So an x value of 6 matches up with a u value of 0, and an x value of 8 matches up with a u value of 1. Because it's a definite integral, we don't need to change back to x's. We just treat this as though it's the original problem. We can integrate that by distributing the u to the 4th. And now we can integrate. Add 1 to the exponent. Divide by 6. 2 divided by 6 is 1/3. Add 1 to the exponent. Divide by 5. We are evaluating from 0 to 1. Plug in 1. Give me 1/3 plus 6/5. Plug in 0. Gives me 0. Don't forget about this 2 out here. Get a common denominator. Times 5, so times 5, times 3, so times 3. That looks like 23 over 15 times 2, which is 46 over 15. And that's it. That's the end of the notes. So again, if there's an extra variable out front after you find your du and replace, you're going to solve the u equals equation for x. You can replace x with that, and then you can distribute and integrate.